Hello and welcome to a lesson on dividing whole numbers. So division is basically the process of taking a quantity and splitting it into equal parts. So we're separating or splitting, whatever word you prefer there, a quantity into equal parts. Okay? So in a division problem, the quantity that's being separated, so you start with this whole amount, and let's say you want to divide it up into 3 equal parts. That whole amount that is being divided we call the dividend of our problem. And the quantity that you divide by, so if you took this whole amount, you wanted to divide it into 3 equal parts, that 3 that you're going to divide by, we call that the divisor in our division problem. And the result of the actual division problem is if you take your whole amount and you divide it into equal parts and you say each of those equal parts contains this amount, that amount is called the quotient. Okay, and just like we have different symbols to imply the operation for multiplication, we have different symbols that imply division. So a fraction bar, for instance, is division, or a slash, like a backslash, is division. We can also use the traditional division symbol, and we can also use our division box. I almost drew a square. A division box to put our division problem into. So let's say, for instance, we had 75 and we divided it into 3 equal parts. So if I took 75 and divided it by 3, I could write it like that. So 75 divided by 3 could be written like that. The result would be 25 in each of those parts. Or I could say, what is 75 divided by 3 like this? And again, the answer would be 25. Or I could say 75 divided by 3 like this with the backslash, and again, the result would be 25. Or I could use the division box, so I could say divide 3 into 75 and get a result of 25. So all of these are different ways to show the operation of division with the result. And in any case, the 75, oops, I wanted my highlighter here. The 75 represents the dividend, that is the amount that is being divided. So this is the dividend. Okay, and the 3, the part that's doing the dividing, it's how many equal parts do you want, that part we call the divisor. And the actual result of the division is called the quotient. Okay, so that's just some basic terminology. Now let's talk about some properties before we actually do some division. So one of the properties of division is that if you divide any number by itself, you're going to end up with that with 1, okay? So if I said 8, for example, and I divided it into 8 equal parts, there would be 1 for each of those parts. So the quotient of any number and itself, except for 0, which we'll talk about, is 1. So for instance, 8 divided by 8 is 1, 12 divided by 12 is 1, 25 divided by 25 is 1. And I just wanted to write the variety of ways that you could see division there. The quotient, that means the result of dividing any number and 1, is going to be itself. Oh, excuse me. For instance, 8 divided by 1 is going to be 8. Or 12 divided by 1 is going to be 12, or 25 divided by 1 is going to be 25. And the next property is the quotient property of 0, where the quotient of 0 and any number is 0. So if you said take 0 and divide it into 8 equal parts, well, each of those parts would still have nothing because you had nothing to divide in the first place. So 0 divided by 0 is 0. 0 divided by 12 is 0. 0 divided by 25 is 0. Any quotient of 0 and any number, that means 0 divided by any number, is going to result in a 0. Now if we try to reverse that, if I try to find the quotient of any number and 0, so not 0 and then any number, but the reverse. If I take any number and try to divide it by 0, that is not an actual number. There is no number for a quantity divided by 0. We say that that is undefined. It has not been defined for us as an actual number. And in fact, if you try to put it into your calculator, it's going to give you an error or say that it's undefined. So 8 divided by 0 here, we wouldn't say equals because it doesn't equal anything, right? We would say this is undefined. It is not defined. Okay, same thing here. 12 divided by 0. It's like having 12 parts of nothing. You just can't do it. Again, not going to put an equal there. We're just going to say it's undefined. And then the same thing here. 25, the backslash 0 means 25 is being divided by 0. That is undefined or not defined. Or if you just wanted to abbreviate UND, that would be completely fine. Okay? So how do we do division? Some of it, if we know our multiplication tables, because this is kind of the reverse, it's not so bad. Sometimes, if we, you can't take these larger numbers and necessarily divide them in your head or use your multiplication tables to know, we might have to perform long division. And it may have been a while since you've seen long division, but basically we repeat 3 operations. We divide, we multiply, and we subtract over and over and over until we get to the end of our dividend or until we have a remainder, which may or may not happen. So when we start the division process, we start with division. When we start the long division problem, we start with division, and we're going to say divide our divisor into the first part of our dividend. If it's a larger number, we can't go into the whole thing. We're just going to look at the first part. And the result that we get is going to go above our division box, and it's going to represent the first part of our quotient. Once we have that there, we multiply. And I will model this, I promise. Multiply the quotient, the first part that we got in that last step there, by our entire divisor. And that result is going to go under the dividend, and then we will subtract it. From there, we bring down the next digit, and we repeat that process. Maybe 2, 3, depends on the place value of the number we're looking at. But we repeat the divide, multiply, subtract until we're at the end of our quotient, and you may or may not have a remainder. So it may go in evenly, and it may not, and I'll show you what to do. Okay, so let's look at some division. For instance, if I said take 28 and divide it by 2, that's something we should be able to do. 28 divided by 2, or cut in half, basically, is going to be 14. I don't need much help with that. Or 36 divided by 9, I know is going to be 4. If I took 36 and made 9 equal parts, there'd be 4 in each of those parts. Or 54 divided by 9 would be 6. Okay, and that can all be confirmed with your calculator or Desmos. So remember, if we put in 28, hit the divide button, and put the 2 in there, it might look a little different than it is on our paper, but it's 14. Okay, or again, 36 divided by 9 was the last one, and we got 4, and so on. Okay, now where we might want the long division is something like this. How many times is 5 going to go into 3,705? So for a problem like this, I would probably use, if I didn't have a calculator, or if I wasn't going to use a calculator, I would use the long division process, where we're going to put our dividend inside the box and our divisor outside of the box. So we start this with division, and I want to see how many times our divisor goes into the first part of our dividend. But 5 doesn't go into 3, which means I have to look at the first 2 digits. So I'm looking at how many times does 5 go into 37. Well, 5 goes into 37 7 times. That's the first part of my answer. And 7 times 5, we multiply here, is going to be 35. That's going to be subtracted from the 37, so I see what's left over, which is 2. So again, I divided here. I got 7. I multiplied here to get 35, and then I subtracted to get 2. Okay, so now I'm here, and I'm going to bring down my next digit, which is a 0, and repeat that process. So I'm dividing 20 by 5. 5 goes into 24 times, so 4 is the next part of my quotient. And then I'm going to multiply 5 times 4 to get 20, and then I'm going to subtract. When I subtract, I end up with 0. And then I bring down the 5, and I do it again. So divide, 5 divided by 5 is going to be 1. multiply. 1 times 5, I get 5. And then lastly, subtract. And since I end up with 0 here, and there's nothing, no other digits to bring down, then that is my answer with no remainder. So this is going to be exactly 741. And again, that could be confirmed. Let's take 3,705 and divide it by 5, and there it is, 741. Okay? Let's try that again. So this time we're going to go 9 is going to divide into 1,872. And so we're going to say, how many times does 9 go into that first part of the dividend? So 9 goes into 18 twice. So 2 is the first part of my quotient. And I'm going to multiply 9 times 2, which makes 18. That goes under my dividend, and I subtract. Now 18 minus 18 is 0. I'm going to bring down my next digit, and then try this again. How many times does 9 go into 7? Well, it doesn't go into 7, so I'm going to put a 0 here. And 0 times 9 gives me 0. If I subtract, I still have 7. Now I can bring down the 2 and go again. 72 divided by 9 is going to be 8. Next part of my answer, 8 gets multiplied by 9 to make 72. And when we subtract 72 from 72, we have no remainder, no digits left to bring down, so this is going to be exactly 208. Okay, so again, I can check this. 1,872 divided by 9 is exactly 208. And just so you are aware, if you multiplied this back out, if you wanted to work backwards, also 208 times 9 will take you back to 1,872. Remember, those are opposite operations, so I could also take 9 and say, when I multiply it by 208, I better get back to my 1,872, and in fact I do. Okay, so we can use multiplying to check our work here. Alright, let's try another one. So we have 7 to go into 2,557. So first, how many times does 7 go into 25? It's going to be 3 times. And 3 times 7 when I multiply is 21. I'm going to subtract. That gives me 4. I'm going to bring down the 5 and do that again. 45 divided by 7 is going to be 6. 6 times 7 makes 42. When I subtract, I have 3. I'm going to bring down the 7 and do this again. This time 37 divided by 7 is 5. So 5 here times the 7 gives me 35. When I subtract, I have 2 left over. Now since I have no other digits to bring down, that makes 2 my remainder. So I could say that this result is 365 with a remainder of 2. Now that's a kind of a simplistic way to write this. Later on when we start learning more about fractions, I'll show you a more appropriate way to write the remainder, but for now it's a remainder of 2. So if we wanted to use multiplication to check this one, if I took 7 and multiplied it by 365, it's not going to take me back to 2,557, but if I add back in that remainder of 2, then it does. Okay, so if I wanted to multiply to check my work on this one, multiplying here and then adding the 2 would take me back to the 2,557. Okay, that's kind of a useful thing. And the farther you go in math, the more useful it becomes. All right, let's try another. Ooh, a bigger number this time. So we're looking at 8 into 56,717. And alright, so we'll start here. 8 goes into 56 7 times. So 7 times 56, or times 8 is 56. When I subtract, I get 0. When I bring down the next digit, I see that 8's not going to go into 7. So I'm going to put a 0 here. 0 times 8 is 0. When I subtract, I still have 7 left. Now I can bring down the 1 and actually divide. 71 divided by 8. Well, 8 times 9 is 72. That's too big. And so this is going to be an 8 here. 8 times 8 is 64. When I subtract, I have 7 left. and then I bring down the 7. It's a lot of 7s here. That will go in, 8 will go into 77 9 times. 9 times 8 is 72. And when I subtract, I have a remainder of 5. And nothing else to bring down, so again, that has to be my remainder. So I'm looking at 7,089 with the remainder of 5 in this problem. So again, if I took 7,089 multiplied by 8 and then added in my remainder of 5, it should take me back to my dividend, which is 56,717. And just to be safe, because I have made mistakes before, let me divide this. And look, so when you have a remainder, your calculator is going to show you a decimal amount, okay? So it's not actually going to do the work for you, but you know that 7,889 is the right quotient. So then if we took 7,089, multiplied it by 8, and we could see the difference between that and our quotient, which was 56,717, is the remainder of 5 that we were left with, okay? So if you try to check one that has a remainder in your calculator, it's not going to show you the remainder because there's a different way to write the remainder, but it will show you the quotient, okay? And you can still use it to figure out the remainder. All right, let's try one more, dividing by a 2-digit number this time. This is a little tougher when the numbers get a little bigger, so let's try. 23 is going to divide into 1,358. So 23 is not going to go into 13, which means we're looking at how many times it goes into 135. And I don't know multiples of 23 very well, so we can just try here. Let's say we tried 4, and when I multiply 4 times 23, well, 4 times 3 would be 12. If I carry the 1, 4 times 3 is 8 plus 1 is 9. I know that I haven't gone to a big enough number because my remainder, 43, is bigger than the 23 that I have there. So I need to try to go a little farther. And in fact, you can use your calculator to do that little part if you want. Say, what is 135 divided by 23? And it's going to say it's 5 point something. So we know that 5 is going to be the correct number. So 5 times 23. Well, 5 times 3 is 15. So I carry the 1. 5 times 2 is 10 plus 1 is 11. So I'm going to have 115 there. And I'm going to subtract it, which is going to give me 20 left over, and I'm good now because 20 is less than my divisor. Okay, so I'm going to bring down the 8 and then try again. Now multiplying by, let's see, I just looking at 20 for instance, times 6 would be 120. That's not going to be here. That's too small. Let's just give 1 a whirl here. Let's say we went times 7. 7 times 3 is 21, so that's 1, carry the 2. 7 times 2 is 14, that's 15, 16 there. And yeah, my remainder is going to be too big. So let me try 8. 8 times 3 is 24, so there's 4. I'm going to carry the 2. 8 times 2 is 16, plus 2 is going to be 18 here. And am I good now? Let's see, 24, nope. Okay, still not good enough. And a calculator is great for this too, but I just want to show you that it's not a perfect process. So, oops, I think I erased a little too much. Yes, I erased all my quotient here. Alright, so 8 wasn't enough. Let's go with 9. 9 times 3 is 27. So 7, carry the 2. 9 times 2 is 18, and that's 19 and 20 there. So 207, which is perfect. When I subtract now, I get 1, and there isn't another digit to bring down, which means 1 is my remainder. So this is going to be 59 with a remainder of 1. So again, I can do 23. Multiply it by 59 and add that remainder of 1, and it takes me back to my dividend. And if I see with my calculator here 1,358, if I divide it by 23, I know I at least have the right quotient of 59, right? And then I can work backwards to try to find the remainder if necessary. Okay? So there's long division, fun times. Let me just show you a couple of applications of division. So for instance, on number 9, We have 3 college students. They share a paper route to earn money, and the total in their fund after expenses is $2,895. It says how much is each person's share. So that $2,895 is being divided amongst the 3 college students. So we want to divide $2,895 by 3. And I'm going to use my long division box here, so I can't do that so well in my head. So let's see. 3 is going to go into 28 9 times. 9 times 3 makes 27. If I subtract, I get 1. 3 is going to go into 19 6 times. 6 times 3 is going to make 18. I'm going to subtract, get 1, bring down the 5, and then 3 goes into 15 5 times. 5 times 3 is exactly 15, so no remainder. And I could scooch that up a little bit. So no remainder. That means each student gets exactly $965. So $965 per student. Now, when you do this in when you do this in Canvas on your assignment, it's not going to want any units, so just enter the 965, no $sign, no words. Otherwise, it's going to kick it back out. Okay. How about another? As part of a promotion, an executive receives 238 cards, each good. Apologies for the typo there, for 1 free song download. If she wants to share them evenly with 19 friends, how many downloads will each friend receive? How many will be left over? So we have 238 cards to divide amongst 19 friends. So we're going to go with 19 into 238. And 19 is going to go into 23 once. If I subtract, I'm going to have 4 left. And 19 is going to go into 48. Let's see, 3 times would be too much, so twice. 2 times 19 is going to be 38. If I subtract, I have 10 left over. I know I'm good because that's less than my divisor. So there it is. So we went in evenly 12 times. That means each of the 19 friends can get 12 of those cards for downloads, but there are 10 left over she won't be able to distribute because she only has the 10 left and 19 friends. So if she doesn't want to make an uneven amount there, make anyone jealous, then each friend, for each fried, guys, jeez. Let's just say 12 cards / downloads, whatever you want to call them, per friend, with 10 left over. The leftovers being the remainders. Okay? All right, last one is actually a pretty useful one, probably something you've seen before. It says a mathematics instructor is checking a simple program she wrote for averaging the scores of her students, and to do so, to check this program, she averages the students' scores of 75, 96, 81, and 88 by hand, and we're asked to find the average score. So this is a statistical item technically, but it's an application of our addition and division. So to find an average, we're trying to basically find what's in the middle of our numbers. And the way we do that is to add all of the numbers up and divide by how many numbers there were. So the average, as we have here in the box, is the sum of our numbers divided by the amount of numbers we have. So in this case, we want to find the sum of the quiz scores, the sum of the scores, and we want to divide by the number of quizzes. Okay, so how many, we're going to add up, let's say the average here is going to equal, we're going to add up the 75, the 96, the 81, and the 88, and then that's going to be divided. Let's figure out this part. Actually, let's call this the sum. Okay, the sum is, I'm going to go ahead and use my calculator because I just don't feel like adding all these things, and I'm sure you don't either. 75, 96, 81, and 88. Okay, so 340 is the sum. So the sum is 340. Now, according to our average formula here, to find an average after we find the sum, we want to divide by the number of quiz scores. So the number of quizzes is, well, I don't know that they're quizzes. I'm just assuming they're quizzes. So there are 4 scores, right? So you find the sum, you add them all up, you get 340, and then you want to divide by how many there were. So there are 1, 2, 3, 4 items, 4 scores in this case. So the number that we're dividing by is 4. So the average is 340 divided by 4, which, let's see, 340 divided by 4 is exactly 85. So this is 85. So this is an average of 85. So whatever it is that you're averaging, in this case their scores for some student, and who knows what it was I said quizzes, but I just threw that word in there. You add up, you find the sum, take all the numbers that you're trying to average out, you add them up, and then you divide by how many individual numbers there were. So if you added 5 numbers together, you would divide by 5. If you're adding 4 numbers together, divide by 4. If you're adding 3 numbers together, divide by 3. Whatever it is, that's the bottom of your fraction. Okay? I think you've got enough to go on to work through your practice assignment, but if you find yourself needing some extra help, then just reach out. All right, take care.